This is recording 1A on multiplying and dividing rational expressions for Unit 6, Chapter 6, Mathematics 2200. And as the title says, I'll kind of, in a silly way, say, we're going to focus on multiplying and dividing rational expressions. Let's see, multiplying rational expressions. Let's work on that first. Rational expressions are multiplied in a manner similar to multiplying fractions. So, for example, 4/9 times 27 over 16. That's equal to 4 times 27 over 9 times 16, which gives us 108 over 144. Now that should be simplified. Not really difficult, I suppose, but it is a little difficult. An easier way to do this problem is this. We really have 4 times 27 over 9 times 16. And we just factor everything that we can so we can simplify before we multiply everything out. So 27, for example, can be thought of as 9 times 3. And in the bottom we have 9 already down there. And the 16 can be thought of as 4 times 4. Now what's nice about that is the 9 divides into the 9 to get 1. 4 divides into the 4 to get 1. And looky look. We've got 3/4, all while the numbers are smaller and easier to work with. We'd like to apply the same sort of thinking to the multiplication of two rational expressions. We factor this numerator as a minus 4, a plus 3. The denominator here is a plus 3, a minus 3. Now we're multiplying here, so really this is all joined together. We're really multiplying the numerators together. So I just need to factor this numerator here, and I've got a minus 3, a minus 1. And in the denominator, I have a outside of a minus 4 because of the common factor. Now before we simplify that, our non-permissible values are the roots of the denominator. So we should be able to read those pretty quickly now at this stage of the chapter. A equals negative 3, so that's one of them. A equals 3 is the next one from the second factor. A equals 0, and A equals 4 are the non-permissible values. Now we can divide our like factors and write the simplified expression. So let's do that. So I've got a minus 4 divides by a minus 4 to get 1s. A plus 3 divides by a plus 3 to get 1s there again. We've got an a minus 3 divides by an a minus 3 to get 1s. And we are left with a minus 1 over a. Our restrictions are a cannot be negative 3, 3, 0, or 4. Now, dividing rational expressions is like dividing fractions. We multiply by the reciprocal. That's at least one way to do it. Your book does offer another way. I'm going to stick with multiplying by the reciprocal of the divisor. So the second fraction is called your divisor, and we multiply by the reciprocal. From there it becomes a problem in multiplication like before. So I won't take that problem to its final simplified form because now it's a problem like I did on the second or the very first slide with multiplying rational expressions. Let's take it over to a dividing problem though. Okay, so we've got a division problem here. We factor the numerators and denominators again. So the first numerator is a minus 4, a plus 3. The first denominator is a minus 3, a plus 3 because of the difference of squares. And we are dividing by a outside of a minus 4 over a minus 3, a minus 1. So everything is looking pretty familiar so far, but look at this second step. Determine the non-permissible values, first of all, before taking the reciprocal of the divisor. So when we take, before we take the reciprocal, our non-permissible values are a equals 3, a equals negative 3, a equals positive 3 from this one, and a equals 1. Now, after taking the reciprocal of the divisor, though, because that's what we have to do when we divide, we've got a minus 4, a plus 3 over a minus 3, a plus 3 times the reciprocal is a minus 3, a minus 1 over a outside of a minus 4. Now we have to inspect. That gives two more non-permissible values. A equals 0 and a equals 4. So these two come from after we take the reciprocal right here. So now it's the multiplication problem, just like in example 1. A minus 4s divide to give 1s, a plus 3s divide to give 1s, a minus 3s divide to give 1s. We are left with a minus 1 over a. The only difference is we have a different set of non-permissible values. We have 3, negative 3, 1, 0, and 4. In conclusion, rational expressions can be multiplied and divided in manners similar to multiplying fractions. When multiplying rational expressions, the non-permissible values are the roots of the denominators. And when dividing rational expressions, the non-permissible values are the roots of the denominators, as well as the roots for the numerator of the divisor because of taking the reciprocal.